What's up YouTube? Now by clicking this video, I'm assuming you're looking to learn more about smart contract development, particularly about value types. Now like traditional programming languages, Solidity has basic data types such as integers, unsigned integers, structs, arrays, as well as mappings. Now in this video, we're going to be discussing the different data types that exist within Solidity. These data types can be classified as either static or dynamic, or value types as well as reference types. Now in this video, we're only going to be focusing on value types. We're going to be talking about what value types are, as well as we're going to be showing you examples of value types. All right, so let's talk about what exactly are value types. Now, a value type is a data type that holds the data directly in the memory owned by it. So variables of these types are always passed by value, meaning that they are always copied when assigned to another variable or passed into a function. So let's go over some of the different examples of value types. Let's start off by making a contract. I'll name it VT for value type. And we'll create a Boolean, and we will make this Boolean public. The Boolean will be denoted by A, and it will be equal to true. Now we are declaring this variable public to permanently store it in the contract storage. Remember, just like in other programming languages, bools or booleans can only be true or false. Now we are declaring this variable public to permanently store it in the contract storage. Next, let's look at unsigned integers. Once again, I'm going to make it public, and I'm going to denote it by B, and it is going to be equal to 50. Now, an unsigned integer only supports numbers that are greater than 0. So that basically means no negative numbers. They cannot be a floating point number. Basically, they cannot have any decimal points. Now, an unsigned integer can be denoted also, as we stated here, as an unsigned integer 256. There are varying ranges of unsigned integers with different ranges as well. Another one is unsigned integer 8, and this can range anywhere between 0 to 2 to the 8th minus 1 power. As well as unsigned integer 16, which can range from 0 to 2 to the 16th power minus 1. This goes all the way up to unsigned integer 256 in increments of 8. Now this is the most common unsigned integer that you will be using within Solidity. Next, let's go ahead and look at regular integers. Now, regular integers allow you to use both negative and positive numbers. We are going to denote this integer C is equal to negative 50 to show that integers can also be negative numbers. Now, integers also have their own alias, namely int 256, which can range from negative 2 to the 255th minus 1 power, all the way to 2 to the 255th minus 1 power. Now, memorizing the ranges for different unsigned integers and integer types can be rather difficult. So Solidity has built-in operators that can help us with this problem. So to demonstrate, I will make an integer public, and let's go ahead and call this min int. Now, we want to find out the minimums and the maximums of these different ranges. So we're going to use type int.min, and we could also use it to find the maximum. We'll name this one max int equals type int.max. Now the next value type that we're going to be looking at is address. Now address is another value type that is commonly used within Solidity. So we will make this address public, and we will denote it addy1. And I just grabbed a random address from Etherscan. Now the next value type that we're going to be looking at is bytes. Now, bytes32 can hold an arbitrary binary data. So let's go ahead and make this public, and we'll call it addy2. Once again, I just grabbed a random address from online. Now, you'll encounter this data type when you're working with cryptographic hash functions. Now, you can use this type for any series of bytes that represent some data. Now, in Solidity, it is not very convenient to manipulate strings, so oftentimes people use bytes32 if they know that the size of the string will not exceed 32 bytes. Lastly, let's go ahead and look at enums. Now, enums in Solidity are a way to create user-defined types. Enums are explicitly convertible to integer types, but not implicitly. Now, enum values are numbered in the order that they are defined, starting all the way from 0. Now, enums are particularly useful. Because of this, I went ahead and made a separate video breaking down what enums are and how to use them in a more intricate way. Go ahead and click this link on the top of the video so you could go ahead and check out that enum video. But for now, let's just go ahead and do a general overview of what enums are. So we're going to call this enum actions. And I'm going to provide 4 different options for this enum. So the first one is going to be go up. The second one is going to be go down. The third one is going to be go left. The fourth one is going to be go right. And let's just add one more in for good measure. The last one is going to be sit still. Now let's create a variable of that enum named choice. Next, let's create a constant called default choice that will hold a default value. And there you have it. Now, these aren't all the value types that Solidity offers. However, these are the most common value types that you will be using when developing your smart contracts. Look out for the next video on reference types. Till then, I'll see you in the next